Hello and welcome to my channel. My name is Vedran Kesagic and today I will tell you about SQL Server. Can it make mistake, human-like mistake, like 2 + 2 = 5? We all rely on data and accuracy of the data in our databases, so this is very important. Watch. Well, some may think that this error can be because, for example, overflow of the data type, but we won't overflow. We'll use, let's say, smaller numbers that fit into integer or money. We'll use precise data types. Some may think maybe it is because, for example, sun sends solar wind, which is plasma charged plasma, hot plasma, which travels in all directions, and some of those are hitting the earth, and this charged plasma can disrupt work of any electric device, including computers. So maybe that's it. I don't think so, because we have a magnetic shield around the earth that sends this, that redirects this hot solar wind into polar regions. So we have aurora borealis, or northern light, on South Pole, around the South Pole, and around the North Pole. So that will not be it. Some may think maybe it is because of no-lock. You know, if you have the code with no-lock hint sprinkled all over the code, please don't use that. Or read uncommitted. They can do what is called dirty reads, reading other sessions' data, which is not committed or maybe never committed, so you're reading the data, you have inconsistent result. Don't use it. You have much better option you will see later. Some may think, I don't know, what can cause this kind of error, if not that? Well, let's see in the demo. Let me grab my laptop, literally in lab. So think about me, I'm a Microsoft certified master and with a lot of experience with SQL Server. I like to give presentations and trainings, and I also solve performance issues and anything related with SQL Server for companies that have SQL Server. So let's see the demo. Can sum be wrong? So simple operation as sum, 2 + 2. Can that be wrong? Let's see. We have one table in our TempDB. It has amount of 10 cents each row and 10 million rows. That means sum of that should be, because it is 10 cents, 10 million rows, that means sum must be 1 million. So let's check that. It has a clustered index on street ID, country ID. So, simple table. Let's do a simple sum. 1 million. So these are 6 digits. 1 million. Looks right, okay? But what if we do update in other session? So in other session we will update street, just the street address. We will update the street address to some other value. It is unrelated to amount. We don't touch amount. Amount stays the same. We don't change anything related to amount. We don't add rows. We don't delete rows. Row stays the same. We're just changing some unrelated column. Okay? So let's do that. First, I will start a loop that will print a sum every 1 second. So let's do that. Print me sum every 1 second. Looks good. 1 million. Okay, we are good. So let's start updating our streets. Unrelated column. Let's start. Oops, wrong database. Okay. TempDB, it's better database. Okay. Now sum becomes what? It is bigger than million. How can that be if we are not changing amount? We are not changing the rows. We are not changing, adding rows or deleting the rows. Let's stop that. Maybe that's just just a coincidence. So let's do something else. Let's, for example, change it a different way. Again, street, we will change the street. Just to scroll down. Let me scroll down, okay. Now let's start changing it different way. Oh, what I did? I canceled the wrong query, sorry. And this one, no, it's not executing. So we want this one, this loop. Okay, messages. So we need to update the address. Now we have less than 1 million. How can that be? Why this happens? Our amount is wrong, dead wrong, like 2 plus 2 equals 5. It's really wrong. And is it fault of the developer? Developer developed correct code, some. You cannot make mistake around that. So that's correct code. Is data wrong? No, data is correct. We have exactly sum of 1 million inside every moment. So this is mistake of SQL Server. Let's see why. I will stop this and I will stop this. And let's go to explanation. So the explanation is internals of select, how select actually works. When you select, you actually follow an index of the table. If it is a clustered table, then clustered index or some non-clustered index. If it's a heap, you could do a full scan of the heap, but mostly you have a clustered index. So let's say it's index, you follow to read and sum the data. And that index, in default isolation, read committed, your select query is reading the rows, putting the shared locks as a wave. I call it shock wave, schlock wave, shared lock wave. So it looks like this, if you see on the screen. It looks like this, and these shared locks travel across the rows you are actually aggregating. And that shared lock is released immediately after row is read. That means while you are doing your sum and putting shared locks that supposedly should give you consistency, I move the row from the end to beginning, and then your select skipped it completely. So you're reading the rows from this side, and I'm moving your row to the other side. So you won't see that row at all. Or the opposite. You're reading your index, and you already, for example, this is one row I will move. You already sum it up, and after that you release the lock, and I move that row in front of you, so you sum it up again. You sum that row twice. And that's why you can get higher amount than million and lower amount than million. And it's almost random. It happens by default. SQL Server does that by default because default isolation is read committed. Out of the box, you get these errors. If you update any of the column, which is in the index key you are using to sum, and you cannot really watch every index on your database, you are in danger of getting wrong results. Imagine wrong results in financial reports. Can you afford that? Can you afford that risk? No, you need to fix that. And luckily, fix is super easy. Let me show you how it's done. So the fix is, watch now, enable one flag on the database, one bit, one switch, which is called read committed snapshot isolation. It has super effects. It is basically like no lock hint everywhere. That means your select will not place shared locks at all. Instead, they will use version store in TMDB. It is possible to be also in 2019, can be in your database, but okay. And basically, readers will not block writers. Writers will not block readers. And because it doesn't rely on these shared locks, it relies on the row versions, it creates accurate picture of the data when the query started. And that makes your query exact, accurate. You will always get accurate results. And it's really good. It has another super effect, which is non-blocking. So you get effect of no lock without blocking, but you get more exact results, completely exact results, in fact, better than read committed, better than read uncommitted. So it's perfect thing. And the only thing that worries some people is, will it create super high workload on my 10DB? No, it won't. I mean, unless your main command on the database is delete and update, it won't create any measurable. I mean, I measured, you can measure it. I measured it many times. It's always so tiny, so negligible that it's really nothing on 10DB. It's so small overhead on 10DB and vast gain you get. So it's really, I advise you to turn it on. I turn it on everywhere, and I advise you to do so too. On new project immediately, on existing databases also, because some say it's risky, you know, it's different behavior, you're not anymore blocked. But the cases where this will produce you different results are so rare that it's highly unlikely that you'll experience any problem. Of course, it is better to test, but in 99.9% of cases, you will be good just by turning it on. So, highly recommended. Don't use read committed default isolation. Don't use it unless you want to be blocked, you want to wait for locks, and you want inaccurate results. Then you use default isolation level. If you want accurate results, if you don't want to be blocked by readers to block writers and writers to block readers, if you want to be with less blockages, so faster, smoother system with accurate results, enable RCSI, read committed snapshot isolation. Your database will run much smoother, much better. And thank you very much for watching. This is all from this video. If you want more information, this is address of my blog, my email address. You can ask any questions or problems you have. Contact me, and thank you for watching. See you next time. Bye bye.